Hello, everyone, and welcome to this session. I will be taking you through the lead code cut off trees for golf event. This is how I'm going to handle this. I'll read through the question, try to understand it better, and then come up with a solution. That is the code that I'll be coding on this side here where the editor is. So let me go straight to the question. You are asked to cut off all the trees in a forest for a golf event. The forest is represented as an M times N matrix. In this matrix, 0 means the cell cannot be walked through, 1 represents an empty cell that can be walked through, a number greater than 1 represents a tree in a cell that can be walked through, and this number is the tree's height. In one step, you can walk in any of the four directions, that is north, east, south, and west. If you are standing in a cell with a tree, you can choose whether to cut it off. You must cut off the trees in order from shortest to tallest. When you cut off a tree, the value at each cell becomes 1. That is an empty cell, as you have seen here. 1 represents an empty cell that can be walked through. Starting from the point 00, return the minimum steps you need to walk to cut off all the trees. If you cannot cut off all the trees, return -1. We have been given a note here that says the input is generated such that no two trees have the same height, and there is at least one tree that needs to be cut off. So we have the first example here. This is an image. We have a matrix that reads 1, 2, 3, 0, 0, 4, 7, 6, 5. And as you can see, this is the route that you need to take while cutting the trees. So the input, so we have forest equals to um, the items here we have 1, 2, 3, as you can see here, 0, 0, 4, as you can see, and then 7, 6, 5. So for this one, I think these are the steps that one will take to cut off the trees. Then you have explanation here. Following the path above allows you to cut off the trees from shortest to tallest in 6 steps, as you can see here. So, like we read from the description above here, 1 represents an empty cell that can be walked through. As you can see, this is 1. So this is empty, but you can walk through it. We were told 0 represents the cell. 0 means the cell cannot be walked through. So you can't walk through here. And then, as you can see, these are trees because this is greater than 1. A number greater than 1 represents a tree in a cell that can be walked through, and this number is the tree's height. So this is 2, 3, 4, 5, 6, 7. Now let's continue. Example 2, we have 1, 2, 3. Then we have 0, 0, 0, 7, 6, 5. So from the description again, we were told 0 means the cell cannot be walked through. So that means we cannot walk through this cell here. Even though we can cut 2, 3, we are not able to walk through this. So that means, again, from the description, we were told starting from the okay, sorry, if you cannot cut off all the trees, then that means we return -1, and I'm sure that is what they have returned here, -1, because we cannot cut off all the trees, and the instruction says you need to cut off all the trees, so -1. And then we'll go to example 3, which says there's no image, but the input, forest equals to the items 2, 3, 4, 0, 0, 5, S876. So again, we have a root here. So there's no 0 here, like there's a 5. So that means you can cut off all the trees. So the steps that you'll walk here are 6 steps. Then we are given some constraints. So m is equals forest dot strength, dot length, and then n equals forest item I dot length, and then we have 1 is less than or equal to m, n is less than or equal to 50, 0 is less than or equal to forest, item I, j, less than or equal to 10 raised to power 9. Then we are told heights of all trees are distinct. So we'll head straight to our code and try to come up with a solution and see how many, see how if we can be able to solve all the problems that we have been given. Um, sorry. So we see if we can be able to solve all the problems that we have been, all the cases that we have been given. So that is case one, case two, and case three. So we have already been given our solution, our class, that is class solution, and our first function, so that is def cut off tree. So the next thing that I'll need to do is I'll need to I need to initialize grid dimensions. So what I'll do here is I'll start by getting the number of rows and columns in the forest, then store them as rows and columns. So here's the code that should help us with that. So rows, comma, then we have columns, comma, equals to length, length of the forest, and then comma, length, again, sorry, supposed to be length, then forest, item 0. Then once done with that, I hope I've typed everything correct. So rows, columns equals to len forest, then comma len forest, item 0. Then after that, the next thing that we need to do is we need to collect and sort trees by height. So what we'll do here is um, we're going to identify all the trees together with their positions. And then for each cell with a number greater than 1, we need to make sure that we represent a tree with its height, because that is what we were told here. A number greater than 1 represents a tree in a cell that can be walked through, and this number is the tree's height. So what I'll do is I'll create a list comprehension that collects each tree as a tuple. Putting into consideration the tree's height, its row, and its column. And then after this, what I'll do is I'll sort the list by height, which is the first element in each tuple. So let's head straight to the code. So trees equals to sorted into bracket again. Then we'll have forest. So the first thing is the row, then move out of that um, bracket, and then column, and then we'll have a comma here, row again, column, then move out of that bracket. And now for r range rows, then move again out for r in range rows, then for c, which means columns, in range calls, again out. If forest, sorry, if forest, then r, which is row, column is greater than 1. So, like I've said here, we are trying to see we're trying to look at each cell with a number greater than one. Like I said, any cell that has a number greater than one represents the height of a tree. So that is why we are having that there. So after that, what we need to do is we need to define the breadth first, such, and how are we going to do this? So this is going to be okay. This is going to be defined as a helper function under the cut off tree. So it's not going to be like a new function, but it's going to be a helper function here. And its work will just be to perform a breadth first, such, and for this function, what I can say is it's going to be it's going to take a start position and also a target position, and it will return the minimum number of steps needed to reach the target. So if the target is unreachable, like we saw here, then that means we need to return -1. If the place where that tree is located, there is no way we can move from the tree that we previously cut to the tree that is like here. Let me take you to that photograph or that image. So as you can see, if this tree was cut and we are not able to reach this tree because this is a cell that cannot be walked through, then we return -1. So let's go straight to the code and try to work on that. So define, I'm going to call it BFS. I'm not going to type the entire thing. And then we're going to start. Um, so here we'll have a tuple, then a target, tuple again. Then we move out of the bracket. This points to um, an integer. Sorry, there's an error here. It's supposed to be a full colon. Then now what we do after we have defined that function is we need to initialize a queue that starts with the starting position and 0 steps, because again we need to start from somewhere. We'll also initialize a visited set to track the cells that I've already seen, because if you have already cut a tree, then that means you are not going back to cut that tree. That means you're already done with that tree. So you need to make sure you track which cell you visited, whether it was empty, whether it's a cell you cannot walk through, whether it's a cell that had a tree and you've already cut it, so that you don't make any errors while cutting the trees, and also avoid maybe wasting the steps. So let's go to our queue. Sorry, queue, queue like that. Then we can dequeue. So here what we're going to do is we'll start at point zero. Sorry. So start at point zero, and then it's a comma for the bracket. Then move to the next one, comma again, then zero. So this was instructing x, y steps. That means the specific cell. Now we move down here. We also need to track the visited steps, like the visited trees. Let me call them trees instead of steps. So here we set. Where did we start? Then start. So set, start, and that's it. Now, what next? So the next thing that we need to do now is we need to start a while loop that continues as long as the items are in queue. That means if there are no sorry, if there are no empty um, if there are no empty like cells, that means there are trees, or if we are not in zero, that means the loop continues, doesn't stop. So what we need to do is we need to start the while loop, and the while loop comes here. So while q while the queue is still ongoing, doesn't it has not stopped, or there has not been an end to the queue, then that means we continue. So now what I need to do is I need to pop each cell from the queue and store the x and y coordinates, um, and the number of steps taken so far. For example, if you have taken, okay, let's say this is the while loop here, because this one is a continuous one. So if you have taken one, two, three. It needs to store the x and y coordinates and the number of steps taken so far. If it's 4 steps, it keeps on tracking and adding more steps to itself as it keeps on cutting the trees down. So let me have that here. So x, sorry, let me take this down again. So x, comma, y, comma, our steps, and then um, we need to put this as equals to our q dot pop. So this one will pop in it left, pop left. Hope there's no error. So x y comma x comma y comma steps, then q pop left. Okay. So now next step. So what we do here is now we need to check if the target has been reached. And how do we do that? So if the current cell, that is the current cell XY, we're not going to be specific whether it's 0, 0, 0, 1. Let me just call it XY. So if I check, so what I'll need to do is I'll check if the current cell, that is XY, is the target cell. That means if it is, then that means I need to return the steps. If it's not the current, then that means um, you need to return -1. That means there's something that was missing, or maybe you did not get to your target, maybe tree, because you were blocked by a zero. So what we need to do here is um, have an if statement that says into brackets x comma y is equals target, sorry, target full colon. So that means if we have reached the target, then that means we return our steps. Now, after we return our steps, the next thing we need to do is we need to explore four directions, and these directions are up, down, left, and right. So why do we need to do that? Because sometimes you might miss the target. So if the target has not been reached, then there's a need for us to check if the four possible moves up, down, left, and right um, are able to be traversed through using a for loop. So what we do here is for each um, for each direction, I need to calculate the new coordinates. That is the next possible coordinate on x and the next possible coordinate on y. And then after that, I'll need to check if next possible coordinate on x and next possible coordinate on y is within bounds and hasn't been visited so far, and it isn't a blocked cell, that is not a zero or not within this. If it's within this, then that means something is wrong and you're going to get a -1. If it's valid, then the next thing we need to do is to add it to the visited set and queue it with something we normally do. That let me just type it steps is equals sorry, actually not is equals but steps plus one, because like I said here, every step that you go through and you're not blocked by a zero, you keep on it's like incrementing. So whatever you do, it keeps on adding. So long as there's no zero, there's no zero. You are not blocked. So what you're going to do is, um, let's head straight to the code. Let me take this back again. So right here, we are going to have a for loop again. So for um, direction X, direction Y, in, then we open our bracket here, uh, the bracket, minus 1, 0. So that is the first coordinate. Then again, another bracket, we'll have 1, 0, comma, another bracket, and then we have another coordinate, 0, comma, minus 1, and then comma again, another bracket, 0, comma, 1, and then we'll have a full colon here so that we can now start working on it. So the next possible, coordinate that is on X, next possible coordinate, next new possible coordinate on y um, is equals to x plus dx, comma y, sorry, plus dy. Then we'll again move to the next line. If 0, if 0 is less than or equal to nx less than, sorry, rows, and 0 is less than or equal to ny less than columns, and brackets again, n x comma ny, and sorry, not an, or and in visited and forests, and in visited and forests, um, again nx, move out, ny not equal, where is my not equal to 0, full colon. Let's go down. Now, visited, so we're going to add, so visited dot add visited dot add or new coordinate, new coordinate. So visited dot add new coordinate on x, new coordinate on y. Then we move out of that, go down, new line, q dot append bracket again, new coordinate on x, new coordinate on y, and then the steps. So we're going to append the steps that have already been taken as it keeps on moving across the loop. So, or along the loop. So, yeah. So, let me confirm whether there's any error. Okay. Okay. So the next thing we need to do is if this finishes processing all the cells in the queue without reaching the target, we said that we're going to return -1 here. So how are we going to do that? So it's very simple. So we're just going to return a -1, and the -1 needs to be outside the loop. So return -1. That is if the target is unreachable. Now, the next thing that we need to do is just a minute. No, this is within the loop if I'm not wrong. It's not supposed to be inside the loop, but yeah, it's within the loop actually. It's within the loop. So the next thing we need to do now is now let's move outside the loop and try to initialize the starting position and total steps. So this is going to happen within the cutoff definition. So this is going to happen within the cutoff definition. So here I'm going to initialize my starting position at 0, 0. That is the 0, 0 coordinates, and then set total steps to 0. So that at least this will help in accumulating the steps as I go from one tree, moving to the other, and keeping on moving to the other tree, cutting off the trees. Yeah, like that. So let me start with initializing start. Start is equals to 0. Start is equals to 0, 0 coordinates. So 0, comma 0 coordinates. And then now we're going to we're going to assign our total steps variable to 0. So total steps, total underscore steps, steps, a variable equals to, not a plus but equals to 0. And then move to the next thing. Now we need to start processing each tree in order. So what we're going to do here is we're going to loop through each tree in the trees list. And for each tree, what I'll do is I'll call the BFS, that is the the breadth first shortest function, and try to find the shortest path from my current start position to the tree's position. That is tree on the first row to tree on the first row, tree on the first column. So what you're going to do here is we'll have our loop. It's a for loop. So for height, sorry, for height, comma, tr. So tree on that row, tree on that column in steps. Sorry, in trees, not steps, in trees, full colon. Um, so our steps now will be equal to our BFS, then from start, comma, then our coordinates, which automatically will be GRTC, that is tree row, tree column. And then after that, we are going to initialize again an if statement to check if the if the steps taken adds up to -1. So if the steps taken adds up to -1, then that means we need to return a -1. That means there was something that was blocking it. So our if statement, if steps equals -1, then we need to return a statement here. We need to return a -1. So if steps taken equals to -1, then by default, it means there was no tree that there was something messed up with the logic, and some trees were unreachable, and yeah, -1 is the default value that should be returned if you can't reach all the trees. Now we need to move to the next item. So what we do here now, after that this has been achieved, now we need to update the total steps and mark a tree as cut, so that at least we can know whether that cell or that coordinate has no trees. If the tree has not been cut, then that means we cut it. If it's been cut, we need to put it in the visited trees variable, so that we can track them and know whether they were cut down or they are still pending. So now So if I can reach a tree, then like I've said, we need to add the step. Remember, there was a place where we were tracking the steps as well, to total steps. And then, like I've said, we need to at least mark all the trees as cut by setting the forest, that is TR and TC to 1. So one thing we need to understand is this will help us avoid revisiting the trees in future parts, and the path will be clear. People will be able to know this is an empty cell. Uh, this is an empty cell. Sorry, this is a cell you can't walk through. This is an empty cell. This is a cell which has a value that is greater than 1, meaning there's a tree. So let's go straight to the code. So total, sorry, not here but outside. So I need to move down. Then total steps, total underscore steps, plus equals steps. Then so the next thing we need to do is forest tr tc t row t column is equals 1. Then now we move to again start equals to three row comma three column. So what this means is we are cutting the trees by setting each coordinate to 1. So that means the tree is down. And then what this means is we are moving to the position of the cut tree. So yeah, so the next thing, which is the final item that we need to do, we after processing all the trees, there's a need to return now the total steps, which will represent the minimum number of steps needed to cut all the trees in order. And if the trees were reachable, then it's very simple. We're going to get a negative 1. So let's return that statement and see how it goes. So return all the steps. So sorry, total underscore steps. So that's it. So just to confirm whether my code is okay, there are no errors. So we've been given 3 cases: case 1, case 2, and case 3. Okay, let me run and see if things are working as expected. Yeah, that means there's an error here. So let me see where the problem is. So this says if, okay, the error is here. If 0 greater than or equal to nx, and 0. This okay. We need to make sure that these are not in visited, the visited s- coordinates. Let me call them coordinates. So there's something that is missing here. Not in. Okay, an error again. Okay, this is not supposed to be here. Not in visited and forests. Yeah. Okay. Error again. So the error is here. So let me see. So it says too many values to unpack, which expected to. So for dx, dy in, so the error is here. Okay, let me see whether my coordinates are okay or something is missing. So for dx in open is 1 0, comma 1 0, comma 0 minus 1. So I did not close this bracket here. I think that is where the error is. We run again. Okay, an error again. Okay, I think this is where I went wrong. The bracket went outside. That's why we are getting that error. All right, awesome. Seems like it's running. So the first case, that is case one, we were told that is the first example. So as you can see, we have one, two, three. This is the first example, 0, 0, 4, 7, 6, 5. So that means, yeah, we can cut off tree 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 6 steps. So that is the shortest we can take to cut off the trees. And then case two, we were given this example here. Um, that is as you can see, the forest has 1, 2, 3, and then we have 0, 0, 0, 7, 6, 5. So as you can see here, we cannot move to this, and we were told if we cannot cut all the trees, then return -1. If you cannot cut off all the trees, return -1, and that is what the example was giving. So as you can see, we have our -1 here. And then case three again, it was given as a 6. It doesn't have a picture, but we have the items in the matrix. So as you can see, our matrix has 2, 3, 4, 5, sorry, 0, 0, 5, 8, 7, 6. And again, the output is 6. This is the shortest number of, sorry, the shortest, yeah, the shortest number of steps you can take to cut off the trees. So as you can see, all the cases are running and we're getting the accurate values that we were getting in the examples. So yeah, so I hope this is going to help out someone who is working on a lead code, and I also hope it's going to help you understand how to work on such like a problem using Python. I was using Python 3. Yeah, that's it. Thank you for your time.